You know, have you ever been out walking and picked up a rock that just looked different? And you wondered, what's its story? Well, some of those rocks hold secrets from a world that's completely vanished. They aren't just rocks at all. They're messages, a history written in stone, just waiting for us to figure out how to read them. And that's the real mystery we're going to dive into. I mean, how does something that was once alive, a leaf, a shell, a massive dinosaur, how does that become a timeless message written in stone? It's an absolutely epic journey of survival against, well, impossible odds. All right, so let's get the definition straight. What exactly is a fossil? Well, at its core, it's the preserved remains or, and this is important, any evidence of something that was once alive. And that's the key, right? We're not just talking about bones here. A fossil can be a shell, it can be the delicate imprint of a leaf, or it could even be the footprints an animal left behind in the mud millions and millions of years ago. It's easy to think fossils are everywhere, but the truth is, becoming one, it's like winning a cosmic lottery against all odds. It's an incredible, unbelievable victory against all the forces of nature that are constantly trying to break things down and, recycle them. It really is a gauntlet against time. And I'm not exaggerating here, this is an incredibly rare event. For every single fossil we manage to find, just try to imagine the millions, no billions, of organisms that lived and died and just vanished completely without a single trace. And that's what makes every single one we find so unbelievably special. So, this really breaks it down. On one side, you have the fate of pretty much all life. It decomposes, it gets eaten, it breaks down, its nutrients go right back into the ecosystem. The end. But for a tiny, tiny fraction, a completely different path opens up. And that path requires one thing, getting buried, and getting buried fast, protected from everything out there that wants to erase it from history. So, what's the secret recipe for immortality, right? Well, you got to think of it like a perfect storm of conditions. First off, whatever it is, it has to be buried quickly, super quickly. That hides it from scavengers. And what it's buried in matters a whole lot. It needs to be something fine, like mud or sand or even volcanic ash, something that can capture all those little details. You miss these first crucial steps, that's it. The lottery ticket is gone. Okay, so let's say our organism does win that lottery. It gets buried. What happens next? Well, this is where the real magic begins. This is the start of a slow, deliberate transformation where organic matter becomes solid rock. And we're talking a process that unfolds over thousands and even millions of years. This whole thing basically unfolds in four key stages. First, you've got the death and burial, which we already talked about. Then comes the pressure. For thousands, millions of years, more and more layers of sediment pile on top, squishing everything down with incredible weight. And then, the final, most important step, mineralization. Water, full of dissolved minerals, seeps down through all those layers, and those minerals slowly replace the original bone or shell, literally molecule by molecule, until you're left with a perfect replica made of stone. I mean, the time scale here is it's mind-boggling. This is not something that happens overnight. We're talking millions of years. And all that time, that immense pressure, and the slow replacement of minerals, it essentially cooks the remains, turning them into this perfect, rock-like copy of what was once a living thing. And this actually tells us where to go looking for these amazing messages from the past. You'll almost always find fossils in what's called sedimentary rock. Why? Because these rocks are formed gently, layer by layer, from things like mud and sand. The other kinds of rock, like igneous from volcanoes or metamorphic rock, they're formed with so much heat and pressure that they would just completely incinerate or crush any fossil. No chance. Okay, so now we know how they're made, but what can they actually tell us? Well, I like to think of the fossil record as this huge library made of stone. And each different type of fossil, it's like a different kind of book, telling its own unique story about the ancient world. Okay, so let's break down the types. The ones we think of most often are body fossils. These are the actual parts of an organism, bones, teeth, shells. Then you've got something called mold and cast fossils. A mold is just the empty space, the impression left behind, and a cast is what happens when that empty space gets filled in with minerals. And finally, my personal favorite are trace fossils. These aren't the animal itself, but clues it left behind, evidence of its activity. And yeah, trace fossils are so special. I mean, look, a T-Rex skeleton is incredible, absolutely, but a set of fossilized T-Rex footprints? Whoa. That tells you how it walked, how fast it was moving. You might even be able to tell if it was stalking its prey. These fossils show us action. They show us behavior. They give us this dynamic peek into what life was actually like for these ancient creatures. So, why does any of this matter? I mean, why do people dedicate their entire lives to finding these clues in stone? Because when you start piecing it all together, you realize you're not just looking at a bunch of old bones. You're reading the autobiography of planet Earth itself. I mean, what we learn from these fossils is just staggering. We learn about the incredible, sometimes bizarre organisms that lived long, long ago. We can literally watch the story of evolution play out in the rock layers. They tell us about past climates. I mean, finding a fossil of a tropical plant in Antarctica, that tells you that place used to be a very different world. They even show us how the continents themselves have moved around the planet. And that, ultimately, is their true power. Fossils are Earth's own natural history records. They are the real, physical, tangible link that connects the world we live in today to a deep, ancient, and almost unimaginable past. The past that shaped absolutely everything we know. So, I'll leave you with this thought. If fossils really are messages from the past, what does it mean when we find the fossil of an ocean animal on the very top of a mountain? What story is the Earth telling us right there? And what does that reveal about the incredible dynamic power of this amazing, ever-changing planet of ours?